everyone, we are from Group B from IO46 INT, and in this video we will explain about the summary of distribution system from week 1 until week 7. So here is the member of the group. I'm Griselda Wijaya, and I'm here with my friends Ibrahim Nakwa, Askal Askia Zalfa, Ari Ramadan, and Willy Bija. The first topic is introduction in distributed system. So distributed systems are network computer systems in which resources and processes are spread across multiple machines. So there are three components here: centralized, decentralized, and distributed. And these three things is different with their structure. So centralized is single point control, decentralized is multiple, and distributed is a process and resource effective connected to work as a single system. And the key goal here is provide seamless, scalable, and reliable access to shared resources. And the next one, we have design goals and challenges. These design goals, the first one is the resource sharings. It access to service like cloud, storage, streaming, and etc. And the transparency is aimed to mask their distributed nature, covering aspects like access, location, migration, and fault transparency. And the openness is system should support interoperability and flexibility with the policy separated from mechanism to allow adaptability. And the next one is dependability. It ensures reliability, availability, and fault tolerance. And the scalability is managed growth in user, geography, and administration. And the common challenge that we have is network reliability and latency, consistency across distributed data, and the security like confidentiality, integrity, and trust. And the next one, we have types and pitfalls in DS. The types we have, the first one is high performance in distributed computing. It includes parallel computing, cluster, and grid computing, supporting tasks that demand significant computational power. And the next one is information system. It enables integration of application across organization through techniques like remote procedure, calls, and message-oriented middleware. And the last one is pervasive system. It's designed to blend into the user environment, including ubiquitous mobile and sensor network. And the next one is pitfall in development. The common errors include assumptions about network reliability, security, and consistency in topology and latency, which can lead to system complexity and require careful design to mitigate.
Hello, my name is Ibrahim, and today I'll be talking about architectural styles. So the first, most commonly used architectural style is layered architecture, where it organizes systems into layers. And then we have object-based architecture, where components are viewed as objects and communicate through procedural calls, encapsulating data and methods. After that, we have service-oriented architecture, where services are encapsulated as discrete units, and RESTful architectures, where distributed systems are viewed as collections of resources. Moving on to middleware. Middleware acts as the operating system of distributed systems, facilitating communication and data management. Middleware can be adapted for specific applications and has complex control flows that may require interception or adjustments. After that, we have peer-to-peer systems where it involves all the nodes to function both as clients and servers. There's two types: structured versus unstructured. Structured systems use a predefined topology, while unstructured systems rely on random connections and searches, for example, flooding and random walks. Up next, we have hybrid architectures. There's three kinds. The first one is cloud computing, where it is described as a part of four layers: hardware, infrastructure, platform, and application. Then we have edge computing, where servers is placed at the network's edge or closer to the user to improve latency and bandwidth, as well as potentially providing privacy and security. Up next, we have blockchains, which are decentralized systems where transactions are added to the immutable blocks via consensus mechanisms. After that, processes and threads. So threads is the smallest unit of process, allowing for parallel execution of instructions within the same process. Context switching. So thread context switching is much cheaper than the process context switching, since it doesn't require the intervention of the operating system and it shares the same memory space as the process. Multi-threaded clients and servers. So threads help improve performance by hiding network latency, supporting parallelism, and simplifying server design. The advantages are that we can avoid blocking due to input output by switching to another thread. It allows for parallel execution on multi-core processors and reduces the overhead of process creation. Virtualization. So the principles of virtualization is that it allows systems to run multiple virtual machines on the same hardware. And what is a virtual machine? A virtual machine emulates hardware enabling processes to run independently of the physical system. Up next, we have containers, which provide a lightweight alternative to virtual machines by sharing the operating system kernel while isolating processes. After that, we have client-server interaction. So client-server model is basically a server responding to client requests. It can be iterative or concurrent. And then we have stateless versus stateful servers. So stateless servers do not maintain client information between requests, but they improve independence and reducing inconsistencies. Stateful servers track the client interactions, allowing for optimizations like caching and prefetching, but with the risk of inconsistencies if clients or the servers fail. Lastly, we have code migration, where why we should use code migration is migrating code can improve load distribution, minimize communication by moving code closer to the data, and offer flexibility and security. There's two types of mobilities, strong mobility, which involves migrating the entire process, including its execution state, allowing for seamless continuation on the new machine, and weak mobility, which involves migrating only the code and data while the execution restarts. Thank you very much for listening.
My name is Askal, and in this opportunity, I will explain to you about the week 4 of communication. So there are seven layers of OSI, or Open System Interconnection Model. The first one is the physical layer. It's the lowest layer responsible for physical connection between devices, such as this example includes cables, switches, and other physical network interfaces. The second one is data link layer. It ensures reliable data transfer across a single link or local network, such as Ethernet and MAC addresses. The third one is a network layer. It handles data routing, forwarding, and addressing across different networks, such as routers and IP addresses work at this layer. The fourth one is a transport layer. It ensures complete data transfer with reliability and flow control. Protocols like TCP and UDP operates here. The fifth one is a session layer. It manages and maintains connection or session between devices. The sixth one is a presentation layer. It translates data between application and network formats, such as JPEG, GIF, and other common encryption standards. The seventh one, the last one, is the closest layer to the user application layer. It provides network services directly to the application, such as HTTP, FTP, or SMTP. So what is the difference between transient and persistent, and synchronous and asynchronous? So first, transient and persistent refers to message storage duration and availability. In transient, messages are stored only temporarily in the system and are discarded if the recipient is unavailable when the message is sent. But in persistent, messages are stored until the recipient retrieves them, regardless of whether they are available when the message is sent. While synchronous and asynchronous refers to timing and interactivity during communication. In synchronous communication, both the sender and receiver must be active and available simultaneously. In asynchronous, however, the sender and receiver do not need to be active at the same time. And last one, there are three gossip protocols that are commonly used, and these three are especially highlighted on the slide. The first one is epidemic protocol. This protocol mimics the spread of diseases where nodes randomly select others to share data with. It is effective, but it can lead to redundant messages and high bandwidth usage. The second one is anti-entropy. In this protocol, nodes periodically synchronize by comparing data and resolving differences to achieve consistency. It is highly effective too, though it can be slower due to its periodic synchronization. And the third one is a rumor spreading or rumor mongering. In its approach, nodes only spread new information to random peers until they no longer appear fresh. And this method is efficient in terms of bandwidth and reduce message spreading over time, though it may not always reach every node, making it less reliable.
I will explain about distribute system, and we have some distribute system like physical clock and logical clock, and then we have advantage and disadvantage itself. So the main purpose of physical clock in a distributed system is to synchronize time between separate devices so that they can operate consistently. This is very important because each node in a distributed system has a clock which can be slightly different. The function of physical clock, the first one time synchronization, sequence of event, and last one time accuracy. And we have two main of time synchronization protocol, NTP and PTP. So let's jump to the next one. This is logical clock. Logical clock are used to maintain consistency and facilitate communication between nodes in distributed system, especially in scenario where the ordering or sequence of event is more important than their actual time. We have some type of logical clock. The first one, Lamport timestamp, vector clock, and hybrid logical clock (ILC). And function and use of logical clock. We have determine the relative order of event, coordination between nodes, and prevent race condition. And next, jump to the advantage and disadvantage of physical clock. Some advantage of physical clock, we have accurate time representation, time synchronization between system, and so on. And for disadvantage, it has difficulty in perfect synchronization, susceptibility to inaccuracy and clock drift, limitation in maintaining causal ordering, and so on. So let's jump to the next one. This is the advantage of logical clock, and the advantage of logical clock. The first one, guarantee causal ordering, doesn't rely on global time synchronization, simple and more resistant to network failure, and so on. And for disadvantage of logical clock, we have doesn't provide real world time, require communication overhead, vector clocks, that data size, growth potential, doesn't guarantee total ordering, and last one, limitation in node failure management. Logical clock are very useful in managing the sequence of event in distributed system, especially when cause-effect relationship are more important than absolute time. However, they have limitation in application that require real-world time or total ordering.
Hello everyone, my name is Ruli and I will explain about naming in distribution system. So basically what is naming? Naming is the process of assigning identifiers or names to resources like files, services, or devices, or any entity that can be accessed over the networks. So basically it's like labeling each resource with a unique tag so we can find it, even if it moves around. And then there are several types of naming. The first one is identifier, which is unique tags that only refer to one specific resource. And then the second one is plate naming, which is a basic method where names are directly tied to location. And then the third one is hierarchical naming, which is a structured system like DNS. And then the fourth one is structure naming, which is use graph or maps to represent connection. And then for the last one is attribute-based naming, which is find resources based on specific traits rather than just names. And then for the consistency and replication distributed system, so why do we replicate data? So by replicating data or making copies, which is improves reliability, so data is always available and speeds up access. However, when we have copies, we need to keep them consistent, meaning they should all be updated in synchronized. And then for the consistency model, there are two types. The first one is data-centric consistency, which is the first one is sequential consistency. And then the second one is casual consistency. And then for the last one is eventual consistency. And then for the second types of consistency model is client-centric consistency, which is the first one is monotonic reads or writes. And then the second one is read your writes. And then for the last one is writes follow reads. And then for the second one is managing replica. So basically there are two of managing replicas, which is placing replicas We're choosing optimal location for data copies, either by setting static location or dynamically placing them based on demand to reduce delay. And then for maintaining content consistency is a method like primary backup system ensure copies that stay in synchronized, while quorum system use spotting to prevent conflicts, only allowing updates when enough replicas agree. And then that's all for me. Thank you.